Start this recording. Okay, so here is, let me just repeat this for the recording. Our first number was x, our second number was y. Our two equations were x equals 4y plus 5, because one number is 5 more, that's plus 5, than 4 times the other. So x equals 4y plus 5. The sum of the two numbers was x plus y equals 10. And when we solved the equation, we got y equal to 1. And substituting, we got x equal to 9. The two numbers are 9 and 1. And that was the answer to number 7 on practice sheet 3. Okay, let's go on to number 8. Number 8 reads this way. Tickets to a local movie were sold for $5 for adult tickets. So they're $5 each. And $3 for students' tickets. If 150 tickets were sold, so a total of 150 tickets were sold, and a total of $610 was what it was sold for. They made $610 for 150 tickets. How many, now here's what's important. We look at what the question asks. How many adult tickets and student tickets were sold? So now let's decide. Let's call X the number of adult tickets. And let's call Y the number of student tickets. Notice I'm not saying let Y be students. Because students, it could be, there are a lot of things that could be about students, how tall the students are. We want to be specific. What does that variable stand for? It stands for how many student tickets were sold. And X stands for how many adult tickets were sold. You have to be clear in your mind what your variables represent. Now we can go back and write our two equations. Remember, we have two variables, we need two equations. The first statement we know is that there are 150 tickets were sold. So some of them are adult tickets, some of them are student tickets. Together, they're 150. So that must mean that X plus Y equals 150, because the total number of tickets sold was 150. The next thing we know has to do with how much money they made. Now, when you're talking about how much money they made, not only do you have to know how many tickets were sold, but how much each ticket went for. So in that case, for the $610, we have to include the fact that the adult tickets were $5 and the student tickets were $3. In other words, my second equation becomes 5x, because it's $5 per ticket times the number of adult tickets. That's how much the adults spent. Plus 3y. That's how much they made on the student tickets. Altogether, they made $610. Notice the second equation includes the money because it's talking about money. Okay, now we can solve the system of equations, and it looks like it's set up for the elimination method. Let's get rid of the y's. It doesn't matter which we get rid of. If we decide to get rid of the y's, then we have to multiply the top equation by 3 and the bottom equation by 1. But since both of these are positive, one of those numbers has to be a negative. Let's say this is the negative. It doesn't make a difference which you pick. So your top equation becomes 3x plus 3y equals 3 times 150, which is 450. Don't forget to multiply across. Use your distributive property all across. The bottom equation becomes negative 5x minus 3y equals negative 610. When I add these two equations down, 3x minus 5x is negative 2x. 3y and negative 3y canceled out. That's what we're looking. We said we wanted to eliminate the y's. That's going to equal 450 minus 610, which is minus 160. I'm going to take out my calculator now. I'm going to divide both of these by negative 2. And that gives me x equals 80. X is how many adult tickets were sold. 80 adult tickets were sold. Now, how do I figure out what the student tickets were? I go back to one of my original equations. I'll go back to this one right at the front. X plus y equals 150. We now know that x is 80, so 80 plus y equals 150. And then subtract 80 from both sides, and that'll give me that y equals 70. In other words, 80 adult tickets were sold and 70 student tickets were sold. And you could just multiply the things together and you'll see that that it works out. Does anybody have any questions about this? Okay, I'm going to continue with this by doing questions number 9 and 10. So let's do number 9. I am going to be erasing this now. Number 9 reads this way. Chad sold 30 decorated sweatshirts. Okay, we're not talking about tickets anymore. We're talking about something else that people are selling. 30 sweatshirts. White ones cost $10. So the white ones cost $10. And the black ones cost $15 each. Now remember, he sold a total of 30. Those are black and white all together. And he received a total of $390. And we want to know how many black shirts he sold. Not asking us to find out both of them, it just want to know how many black shirts were sold. Again, it's this situation where you have a number of things that are being sold, that they're two different types, they have different prices. We know how many were sold all together. We want to know individually what was sold. Again, let's call X the number of black shirts, the number of white shirts. And let's call Y the number of black sweatshirts. Okay, again, I'm being specific. I know exactly what my variables represent. Now remember, they told me that 30 sweatshirts altogether were sold. So that must mean that the X plus Y equals 30. It has nothing to do with how much was spent on the shirts. It's just how many were sold. The next bit of information they gave me has to do with how much money that he made. He made $390. Well, obviously that was because of the price that he sold his sweatshirts for. So therefore, let's write an equation that has to do with the money. So we have to do 10x, that's how much he made for the white sweatshirts, plus 15y, that's how much he's making on the black sweatshirts. That together is going to be the $390. Clearer. Notice they only want us to figure out what y is because they asked us what was how many black shirts were sold. Okay, so let's get rid of the x's because we want to figure out what the y is. In order to get rid of the x, I have to multiply the top equation by 10 and the bottom equation by 1 because I'm using their opposite coefficients. And I have to use a negative with one of them. It doesn't matter which one I call the negative. I put the negative now with the top one. So the top equation then becomes negative 10x minus 10y equals negative 10 times 30, which is negative 300. And the bottom equation multiplying by 1 doesn't change anything. 10x plus 15y equals 390. And when I add these two equations together, the negative 10x and the 10x cancel out. So we said we're eliminating the x. Negative 10y plus 15y gives me a positive 5y. And negative 300 plus 390 gives me positive 90. And when I divide by 5, to get what y is, I get y equal to 90 minus 5, which gives me 18. He sold 18 black sweatshirts. Didn't ask me how many white sweatshirts were sold, so I'm not going to bother figuring that out. Notice it's a similar question, same setup as the one before, just a different numbers and a slightly different scenario. So let's do the last question, number 10. Which is a little bit different than the one. Number 10 tells me that the perimeter of a rectangle is 10 meters. Let's call it P for perimeter. If the length is doubled and the width was increased by 10, the perimeter would be 36. What are the length and width of the perimeter, the rectangle? So let's draw a little diagram here. We have, remember in a rectangle, we have the lengths, they're both the same, and the widths are both the same. There are two lengths that are equal and two widths that are equal, and the perimeter is everything added up together. In other words, if they tell me that my perimeter is 10, it must mean that the 2L plus the 2W, add these two together and these together, those are all the four sides added up, that has to equal 10. That's the first rectangle. Now they're telling me about a second rectangle. Here's a second rectangle. What are they doing on my second rectangle? I'm making the rectangle bigger. The length is being doubled. So the length, instead of being L, is now 2L. Doubled means you're multiplying by 2. So this is 2L and this is 2L. And the width is increased by 10. Increase means you're adding 10 to it. So this width is W plus 10. And this is also W plus 10. So let's remember, doubled or multiplied by 2 or times 2 or twice all means multiply the number by 2. Increased or more than means add. Now, what is the perimeter of this? So the perimeter is going to be, let's add everything up together. W plus 10 plus 2L. It's a little bit more complicated, so I'm doing it all separately. Plus W plus 10 plus 2L. That's its perimeter. All the four sides added up is going to be equal to 36. Well, this was really easy to add. W and W was 2W, L plus L was 2L. This is a little bit more complicated, so I wrote the whole thing out, but I could have done it the same way. Adding the like terms. So here there's a W plus a W, which is 2W. And then there's a 2L and a 2L, which is 4L. And then there's a 10 and a 10, which is 20. All that up adds up to 36. And I'm going to bring this 20 to the other side. So this is going to give me that 2W plus 4L equals 36 minus 20, which is 16. So I had two different rectangles that they were talking about. So now I have two equations. I have the equation that says 2L plus 2W equals 10. And I have the second equation. I'm going to rearrange the terms. I'm going to put the L terms first. The equation that says that 4L plus 2W equals 16. And it's very easy to get rid of the W's by just multiplying one of the equations by -1. You could do it my standard way, and if you want to get rid of the W's, multiply this by 2 and this by -2. But you might see right away, if you multiply the top equation, let's say by -1, you'll get -2L minus 2W equals -10. The bottom equation stays 4L plus 2W equals 16. And when I add these two equations together, -2L plus 4L gives me 2L. That's why I can do it, because now the W's are going to be eliminated. And that equals the -10 plus the 16. So this will give me -10 plus 16, which is 6. And if I divide by 2, it tells me that my L turns out to be 3. The original length of this rectangle, the length of the original rectangle happens to be 3. To find out what its width is, let's go back to this original equation. We have 2L, so that's 2 times 3, plus 2W equals 10. So 6 plus 2W equals 10. And when I subtract 6 from both sides, I get 2W equals 10 minus 6, which is 4. and therefore W equals 2. So in my original rectangle, my original width is 2, my length is 3. They could have asked what are the dimensions, and you could have said the same thing. The length is 2 and the length is 3 and the width is 2. Are there any questions about this one? This one was a little bit harder than the other. Okay, I think that we have finished completely chapter 3. We had started last time with chapter 4. We're going to continue with chapter 4, which is our discussion of polynomials. I'm going to give you a problem to work on while I take attendance. Okay, here's the problem I'd like you to do. Subtract 5x cubed minus 3x squared plus 2x minus 1 from 2x to the third plus 7x plus 13. Let's see if you could do that example while I'm taking attendance. I'm going to put this on pause. It says if there is an invisible 1 in front of each of these parentheses. So when we remove the parentheses, the first parentheses, when we move it, when you multiply everything by 1, it just stays the 2x to the third plus 7x plus 13. And the second polynomial becomes negative 5x to the third plus 3x squared minus 2x plus 1, because when you're multiplying by a negative, all the signs change. And now you just combine the like terms. 2x cubed and negative 5x cubed are like terms because they have the same exponents. You do 2 minus 5, you get negative 3x to the third. The next thing you look for is an x squared term, and there's just one x squared term. There's a plus 3x squared, so there's nothing to combine it with. We just bring it down. Then we look for the x's, a 7x and a minus 2x combined to plus 5x. And finally, just the constants, the numbers without any x's are the 13 and the 1, which gives me plus 14. I hope everybody got this answer. This is your answer. Don't forget that the way I put it, it's a degree 3 polynomial because the highest exponent I'm seeing is 3. And this is in what we call descending order because the highest exponent is first, then the next highest, then the next highest, and then finally the number without any, the number without any variable next to it. So this would be your answer when you are subtracting. When you're adding, you just would put a plus instead of a minus, and then combine the like terms that way. So that was multiplication, and we were up to, that was adding and subtraction, and we were up to multiplying of polynomials. We actually talked about multiplying by a monomial by a polynomial, just using the distributive property. Remember, when you're multiplying the variables together, you have to add their exponents. So let's talk about now multiplication of two polynomials. Let's say I had something like this. Suppose I wanted to multiply 5x minus 2 times 3x plus 7. I'm going to show you the regular way, and then we're going to talk about something called FOIL. When you are multiplying a polynomial by a polynomial, in this case we're multiplying a binomial by a binomial, you take your first polynomial and you take your first term in your first polynomial and multiply everything in the second polynomial by that first term. In other words, I'm going to take the 5x and multiply it by 3x. So 5 times 3 will give me 15. X times x gives me x squared. Remember, any term that doesn't have an exponent, any letter that doesn't have an exponent, it's understood that its exponent is 1. So 1 plus 1 would give us 2. So we multiply the 5x times the 3x. We now go back and take the 5x and multiply it by the 7. So 5 times 7 is 35. There's only one x here, so I just bring it down. I have now multiplied everything in my second parentheses by this first term of 5x. I now go to my second term, which is negative 2. And I do negative 2 times 3x, and that gives me negative 6x. And finally, I take the negative 2 and multiply it by the 7, which gives me negative 14. I have two terms that I multiply by two terms. I end up with a total of 4 terms in my answer before I've combined anything, because I've multiplied everything in my first parentheses by everything in my second. The last thing I have to do is see, are there any like terms? And I do see like terms. The 35x and the negative 6x are like terms, so they can be combined. So my final answer becomes 15x squared. 35 minus 6 is 29, plus 29x minus 14. And we ended up, by multiplying two binomials, we ended up with a trinomial of 3 terms, and that's most common scenario. It doesn't always happen to be. Sometimes there are no like terms, but most of the time, 2 of the terms are like, and you end up with a trinomial. This is sometimes explained as being FOIL. When FOIL is the process that's used when you're multiplying two binomials. How does FOIL work? Well, it's just explaining exactly what we just did. F stands for first. We take the first two terms, the 5x and the 3x, and we multiply them together. That's what we did, and we got 15x squared. Then we do O, which stands for outer. Outer means the two terms that are furthest away from each other. The first one and the last one, the 5x and the plus 7. Now, if we multiply the 5x times the 7, that's where the 35x came from. That's our second term. The I stands for inner. The inner terms are the ones that are closest together. The ones that are really just separated by the parenthesis signs and not separated by anything else, and no pluses or minuses in between them. That's the -2 and the 3x. When we multiply the -2 and the 3x, we get -6x. And finally, the L stands for last. So the two last terms are -2 and 7, +7, and that gives us the -14. Notice again that usually the outer and the inners are like terms, and usually they combine. So saying FOIL is just a quick way of saying you're multiplying four things when you're multiplying two binomials. First, outer, inner, last. Again, combine your like terms. Here, I'm going to give you one to try now. Try. I'll start you off. Suppose I were to give you 3x minus 4, parentheses, with an exponent of 2 on the outside. I just want to remind you, when you are squaring a binomial, what you're basically doing is you're multiplying the binomial by itself. So when you actually want to do the work, you want to write it twice. You want to write the 3x minus 4 times the 3x minus 4. Okay, I'm giving you a minute to try and do this one. Okay. Okay, I see you, Kaimani. imagine they were busy in the nursery, so they sent it. Obviously, he's. Because he was born like 1.8 or something. She was pumping. She said she tried, and they said she could try nursing him also, but they should really get the bond because right. Okay, great. I see some people have come up with the answer. So let's just do it. Okay, good. A few people have come up with the answer. Doing, again, I'm going to call it FOIL first. 9x, 3x times 3x is 9x squared. Outer is 3x times -4 is -12x. Inner is -4 times 3x, which is another -12x. And finally, last, -4 times -4 is +16. Don't forget, be very careful with those signs. And again, we have the two middle terms, the inner and the outer, combining. -12x and -12x is -24x. So your final answer is 9x squared minus 24x and +16. Okay. There are a few other types of questions we could have that have to do with the multiplication. Number one, what if they ask you to multiply 3 polynomials? What if they ask me to multiply x minus 2 times x plus 2 times x minus 3, for example? What if I have something like that? How do I go about doing it? Not so hard. You just take your first 2 polynomials and multiply them together. So I'm going to multiply the x minus 2 times the x plus 2. Look at what we're getting. X times x is x squared first. Outer, x times 2 is plus 2x. Inner, -2 times x is minus 2x. And finally, -2 times +2 is -4. So I'm ignoring this x minus 3. I'm just multiplying these together. I'm going to combine the like terms. If you notice here, the +2x and the -2x, they're the same coefficients, but they're opposite signs, so they cancel each other out. So when I multiply the x minus 2 times the x plus 2, I get x squared minus 4. Now, before I go on to the second part, I just want to remind you, I multiply 2 binomials. Usually my answer is a trinomial. Usually I get 3 terms. Occasionally I will get only 2 terms. That'll happen when the inner and the outer terms cancel each other out. It happens when my 2 binomials look identical, except one has a minus sign in it and one has a positive sign in it. Notice this is x minus 2. This is almost the same thing. It doesn't say x minus 2, it says x plus 2. 2 binomials that look the same except for the middle sign are called conjugate binomials. X minus 2 and x plus 2 are conjugate binomials. Conjugate means that they look the same, but they have a middle sign that is different. Anytime you're multiplying conjugate binomials, you don't get 3 terms, you don't get a trinomial, you only get a binomial. You only get the x and the x, which is x squared, and the -2 and the +2, which is -4. If you recognize that you have conjugate binomials, you can, and you're multiplying them, you can save yourself a little time because you know the middle terms are going to cancel out, and therefore you don't have to even bother with them. You don't have to bother saying, oh, this is a -2x and this is a +2x. I could have right away said x squared -4. Okay, going on with this problem. The x minus 2 times the x plus 2 gave us x squared -4. I still have to multiply it by the x minus 3. Now again, I have 2 binomials and I am multiplying. So I'm going to do the same thing. I'm going to use my FOIL. First, x squared times x. Now be careful. This is an exponent of 2. This has an exponent of 1. So that'll give me x to the 3rd. That's my first term. Then I have outer x squared times -3, which is -3x squared. Inner is -4 times x, which is -4x. And last is -4 times -3, which is +12. And I look here and there are no like terms, so this is my answer. So I can multiply 3 polynomials together by doing first the first 2, getting the answer, and then multiplying it by the 3rd. What happens if I have something like this? What if I have 2x minus 1 times 3x squared plus 7x minus 5? What if it isn't just 2 binomials? What if it's something more complex? What if it has more terms than just 2? I obviously can't use FOIL because FOIL specifically is when you're multiplying a binomial by a binomial. But the concept that you have to take everything in your first parentheses and multiply by everything in its second parentheses works here as well. You take your 2x and multiply everything in this parentheses by 2x. Then you go back and multiply everything by -1. And then you go back and see, are there like terms? Combine the like terms. So we have 2x times 3x squared will give us 6x to the 3rd. Remember, understood exponent of 1 here. Now I have 2x times 7x. That's plus 14x squared. Again, be careful with those exponents. And finally, we have 2x times -5. That's -10x. I have now multiplied everything in my second parentheses by the 2x. I now go back and multiply everything in the second parentheses by the -1. So -1 times 3x squared is -3x squared. -1 times 7x is -7x. And -1 times -5 is plus 5. Okay, so I had 2 terms here times 3 terms here. I end up with a total of 6 multiplications. Let's see if I have any like terms. Well, there's nothing, there's only one x cubed term, so I bring that down, 6x cubed. Then I have a 14x squared and a -3x squared. Those are my x squared terms. 14 minus 3 is 11, so it becomes plus 11x squared. Now I have a -10x and a -7x. Those are like terms, -10 and -7. is negative 17. So I have negative 17x, and finally the plus 5. I end up with only 4 terms in my answer rather than 6 because there were these like terms. But again, the concept of multiplying everything in the polynomial by everything in the second polynomial applies whether you have binomials or something bigger. You could even have 8 terms times 10 terms. Of course, that would mean 80 multiplications. We're not going to do that in class, but if you think about it, you could actually do it. It's just more work, but it's not different work. Here, let's see if you can try one on your own. I'm going to give you one to try. So let's say I have, I'm doing actually question number 11 on practice sheet 4. It's m plus 3n times 2m squared plus 5mn minus 2n. Let's see if you could do this. Well, I'll give you a few minutes to try that. Okay, let's try this together. We're going to take and multiply each term in the second parentheses by the 1m, the m that's over here. So m times 2m squared will give me 2m to the third. Multiplying the m times the 5mn will give me plus 5. Well, the m times the m will be m squared, and I'll just bring down the n. And finally, I'm going to multiply the m times negative 2n. So remember, this is as if it has a 1 in front of it, so it's negative 2. And it's m times n. Now, there's nothing wrong with writing m times n or n times m. The order in which you write the letters in your each term doesn't matter. It's immaterial. So I always try to write them in alphabetical order so that it's sort of organized. Okay, I've now multiplied everything in my second parentheses by the m. I'm now going to take the 3m n and multiply everything by it. So 3n times 2m squared is going to give me plus 6m squared n. Again, I'm just doing things in alphabetical order, and m comes before n. Now I'm doing 3n times 5mn. That's going to give me plus 15. M, there's only one m, but there's an n times an n, so that will give me n squared. Finally, I have 3n times negative 2n, which will give me negative 6n squared. Okay, I've multiplied. I have 2 times 3. I have 1, 2, 3, 4, 5, 6 things. I have to look for like terms. Okay, so there's only one m cubed term, so that becomes 2m to the third. Now I have a m squared m. Is there anything else that's m squared m? And yes, there is. There's this m squared m, there's a 5m squared m, and a 6m squared m. Those are like terms, so we add the 5 and the 6, and we get plus 11 m squared n. Okay, the next thing I see is a 2mn. Is there another mn term? No, this one has mn squared. So there's only one term that's just mn. That's a minus 2mn. Okay, this we took care of already. Here we have a 5mn squared. Now be careful. This is not the same. These are not like terms. Even though they have m and n in this, this has an exponent of 1 and this has an exponent of 2. There's no other term that's like the 15m squared, mn squared, so I bring that down, 15m squared n, 15m n squared, and finally minus, I'll just put it underneath here, minus 6n squared. There weren't as many like terms as we would have liked, but that's all there was. And here is my answer. I hope most of you got that answer. Does anybody have any questions before we go on? Okay. So now we know how to add, subtract, and multiply polynomials. Obviously, the next step should be, well, add, subtract, multiply. The next thing is divide. Actually, we don't do division in this chapter. We're going to do division of polynomials a little bit later in the term. It's a little bit more complex, so we're leaving it. But what we are going to do is something called factoring. Factoring is related to division because you are taking something apart. Usually that's what the difference between multiplying, you're sort of putting things together, and dividing, you're taking them apart. So there are two ways of taking something apart. I could take the number 17 and tell you to divide it by 10. Now notice, it's just a matter of going to your calculator and doing 17 divided by 10, and you get 1.7. Doesn't always come out evenly. If you're lucky, you might have something like 15 divided by 3, and that does come out evenly. That comes out to plain 5. So sometimes you get decimals, sometimes you get fractions, sometimes you get whole numbers. That's division. What is factoring then? Factoring is a little bit different concept. I start with a number. Let's say start with a number 20. I don't tell you what to divide it by. When I am factoring, I'm trying to find what were the original numbers that were multiplied to give me 20. So you might tell me, oh, I know that 4 times 5 will give me 20. So one of the factors of 20 is 4. Another factor of 20 is 5. You could have done 2 times 10. You could have done 2 times 2 times 5. There are a lot of ways you could factor. You could break this down. But let's say I figured out that one of my factors is 4. I know that 20 has a factor of 4. That means that when I divide 20 by 4, I will get a whole number answer. 4 is one of the factors of 20. Once you know one of the factors, you can figure out what the other factors simply by dividing. The 20 divided by 4 will give you the 5. So you have to figure out at least one factor, and then you could use division to find the second factor. And again, the factors are not just the 4 individually, and the 4 and the 5 together are the factors of 20. How does that apply to polynomials? So let me give you an example. It's called finding a common monomial factor, or a common factor. Easier name. It's the first type of factoring that we do when we're dealing with polynomials. I could start with something that looks like this: 10x squared minus 15x. When I want to factor, again, when I'm factoring, I'm breaking it down to the 2 original expressions that when I multiply them will give me this answer. It's essentially like I have the answer and I'm going back to what was the question. We just learned how to multiply and we got the answer. Now we're starting with the answer and going back to what was the question. What things did we multiply to get 10x squared minus 15x? And again, the first type of factoring, first type of breaking this down is by finding a common factor. So what does that mean? You look at each of the coefficients, 10 and 15, and think of the largest number that divides evenly into both 10 and 15. What is a common factor of 10 and 15? What number goes evenly into both 10 and 15? And I think everybody realizes it has to be a 5. Then we look at the variables, at the letters. Now, that really is the easier part, because when you're looking at the variables, you make sure that all the terms have the same variable. Well, they both have x's in them, so x is going to be a common factor. And you decide what is the exponent by picking the one with a lower exponent. This term has x to the exponent of 2. This has x to the exponent of 1. The one that's common is the x with an exponent of 1, or in other words, 5x. 5x is a common factor of both 10x squared and negative 15x. Now remember, when we had this 20, and I said one of my factors was 4, we could find the second factor by dividing my original by that factor. In other words, take the 20, divide by 4, it gives you 5. The second factor is 5. The same thing over here. We figured out one factor. The way we figure out our second factor is divide each of the terms in this polynomial by the 5x. So 5 divided by into 10 is 2. And x divided into x squared is x. Remember, when you're dividing polynomials, you subtract their exponents. This has an exponent of 2. This has an exponent of 1. 2 minus 1 is 1. So it's 2x. It just, because its exponent is 1. Then we take the 5x and divide it into the second term. 5 into negative 15 is negative 3. X into x, remember, 1 minus 1, you have an exponent of 0. That means it cancels out. There is going to be no x. So therefore, factoring out this common factor from 10x squared minus 15x gives us 5x on the outside and 2x minus 3 on the inside. It's just the opposite of doing the distributive property. We're undoing the distributive property. Now, some of them are pretty easy. Some of them are more complex. Let's say I gave you something like this. x fourth y squared plus 20 x cubed y to the third plus 10 x squared y squared. Yeah, I'm going to do this one with you, and then you're going to do the next one. Okay, it's a trinomial rather than just a binomial, but it's the same concept. First, look at the coefficients, the numbers in front, 10, 20, and 10. What number, what's the biggest number that goes into 10 and 20? Obviously, it's 10. So our 10 is the beginning of our common factor. Now we're going to start with the letters, with the variables. So let's look first at the x's. There's an x fourth, an x third, and an x squared. So there are x's in each one of these terms. The lowest exponent is the 2, so that's my common factor, x squared. Now I go to the y's. I have a y squared, a y third, and a y squared. Again, all the terms have y in them, and the lowest exponent is 2, so this becomes 10x squared y squared. I have figured out what my common monomial factor is. I now have to figure out what the polynomial that goes inside the parentheses is going to be. So I'm going to divide the 10x squared y squared into each one of these terms. So 10 into 10, that cancels. X squared into x fourth. Remember, we're subtracting exponents. 4 minus 2 is 2, so that gives me an x squared. Here's a y squared into y squared. Whenever you subtract the exponents, you get 0. It means that thing is no longer there. It's really a plain 1, but anything times 1 is just that number. So the first term in my polynomial turns out to be x squared. Okay, then I go 10 into 20. That gives me 2. X squared into x3. The 3 minus 2 is 1, so that just gives me x to the 1, which I write as plain x. Y2 into y3, again, I subtract their exponents. 3 minus 2 is 1, so it's just y to the 1, which is just a plain y. So my second term in this polynomial is 2xy. Finally, I do 10 into 10, it cancels out. X squared into x squared also cancels out because the exponents add up to become 0. Y squared into y squared cancels out. Now here's where you have to be careful. If every single thing cancels out, your answer has to be 1. Because when you cancel out by division, it doesn't mean you don't get anything. It doesn't mean you get 0. It means you get a 1. And if you start out with 3 terms and you're taking out a common factor, your polynomial also has to end up being 3 terms. So don't forget that term, that if everything totally cancels out, don't just drop it. It means that your answer is going to be 1. Because if you divide a number by itself, 10 divided by 10 is not nothing, it's 1. Okay, let's see if you can do one on your own. Okay, I'm giving you the example number 13 on the practice sheet 4. It says 6x to the 4th y squared plus 18x to the 3rd y third minus 24 x squared y fourth. Give you a few minutes to try that. Okay, let's look at this now. First, we want to find our common factor. We first look at the coefficients. 6, 18, and 24. What number goes into all 3 of those numbers? Obviously, there's a lot of them. It could be 2, it could be 3. But the largest one, that's what we're looking for, the largest common factor, is the 6, because 6 goes into each one of those. So I'm going to put my 6 on the outside. Now I start with the variables. X fourth, x cubed, x third, 2 obviously is x2. Then the y's, y2, y3, y4. That's y2. Again, with the letters, we take the lowest exponent. So our greatest common factor is 6x squared, y squared. Now we have to get the other half of this example, we have to find out what do we multiply this 6x squared y squared to get this expression. So we divide. 6 into 6 cancels out. X squared into x fourth gives me x to the 2. Y squared into y squared cancels out. Remembering, if everything cancels out, you put a 1. Otherwise, you just put whatever's there. Okay, that's my first term. Then I do 6 into 18 is positive 3. X squared into x third gives me plain x. Y squared into y third, again, we're subtracting the exponents. It's giving me just a plain y to the 1, which I can write as just y. Now we go to my last term. 6 into negative 24 is negative 4. Always be careful with your signs. X squared into x squared cancels. Y squared into y fourth, again, we subtract the exponents, it gives me y squared. And my answer becomes 6x squared y squared times x squared plus 3xy minus 4y squared. We're not going to talk about if we could break this down any further. That's something we're going to learn a little bit later. We are just looking for the common monomial factor. We have a few more minutes, so I can talk about something called a common binomial factor. You can even have a common binomial factor. Look at something like this. I could have something that looks like this. 5x times a minus 2b minus 3y times a minus 2b. Now, our first reaction is when you see something like this is, oh, let's multiply and get rid of the parentheses. But when we're asked to factor, we really want to put the parentheses in. We don't want to get rid of the parentheses. We want to put them into what they were originally. And if I look at this, I see this binomial, this a minus 2b, is being multiplied by the 5x. And it's the same binomial is being multiplied by negative 3y. In other words, a minus 2b is a binomial that's being multiplied by both of these terms. And therefore, I can take out this common binomial factor. What do? I just take the a minus 2b and put it in front and make another parentheses. And I think if I divided this by this, the a minus 2b's would cancel out, and what I'd be left with is 5x. So my first term becomes 5x. And when I divide the a minus 2b into the second expression, again, that a minus 2b cancels out, and what I'm left with is minus 3y. So I have broken this down into the product of two binomials by taking out, factoring out a common binomial factor. Now, this really can be a big help when we want to factor 4 terms. We're skipping over factoring 2 terms, but let's go on to factoring 4 terms, because I'm going to show you that really factoring 4 terms is just a matter of finding a common binomial factor. For example, if I were to give you something like this, 3xy plus 3y plus 2ax plus 2a. I give you a polynomial with 4 terms. And I tell you, I want you to find factoring. Now, obviously, our first type of factoring that we always look for is going to be find a common factor. Well, let's see, do we have a common factor? Well, this has a 3 and this has a 3, but these only have 2s. So there's no common number that they both have. Let's look at the letters. This has an x, but this doesn't have any x, so x can't be a common factor. This has a y and this has a y, but this doesn't have any y, so y is not a common factor. If I'm looking for a common factor of the whole 4 terms, I'm not finding it. I have to leave it alone. But I can do something that's called grouping. This is called factoring by grouping. What does grouping tell you to do? Split the thing into 2 pieces. You have a total of 4 terms, so group your first terms together and group your second 2 terms together. I put a line there to say I'm working with this separately and this separately. Now, if I look at that, and I just look at the 3xy and the 3y, I can find a common factor sometimes just in the 2 terms. Notice there's a 3 in both of them, so there's a 3 common factor. There's no x, but there is a y in both of them, so 3y is a common factor. And what happens when I divide 3y into 3xy, the 3's cancel out, the y's cancel out, and I'm left with x. Then I divide the 3y into the 3y. Now notice the 3's are canceling out and the y's are canceling out. Remember, when everything cancels out, we're left with a 1. In other words, if I just look at the 2 first terms, I could factor those into the common factor of 3y and the binomial x plus 1. I then go to my second group. There's a 2ax and a 2a. And I try to factor that out. So I have a 2 in both of them, so that's a common factor. And there's an a in both of them, that's a common factor. But there's an x here, but no x here. So my common factor is 2a. And when I divide the 2a into the 2ax, the 2 cancels out and the a cancels out, and I'm left with x. And when I divide the 2a into the 2a, everything cancels out. And remember, when everything cancels out, we're left with a plus 1. So in my first group, I got 3y times x plus 1. And in my second group, I got 2a times x plus 1. And now, in the 2 groups, I see that x plus 1 is a common binomial factor. In the first term, x plus 1 is a factor. In the second group, x plus 1 is a factor. So I could put that x plus 1 in the front. And in my parentheses, well, this will get rid of the x plus 1, will give me 3y. And over here, when I get rid of the word divide out the x plus 1, I'm left with 2a. So my final answer becomes x plus 1 times 3y times 2a. So we took a 4-term expression, a 4-term polynomial, and factored it into 2 binomials. So that's called grouping. Okay, I'm going to stop right here. I'm going to give you some homework on Delta Math, but also on practice sheet 4, you're to do examples 1 through 13. I will send you out, if I haven't sent you out I'm going to send you out the answer key for it, so that you can check your answers. Again, if you have any questions, you can always ask me questions. Does anybody have anything they want to ask me before I end this session? Okay, then have a good afternoon, a good day. I'll see you again on Thursday. Don't forget